Welcome to the Glassworking shop. Well, today I'm going to be trying a couple of new things. I'm continuing to improve my camera and recording setup, so I'll be recording in a different way with a different camera setup, and hopefully everything goes well, but this will be the first time it's tried. Little bit by little bit, I try to improve everything I do, whether it's tools, technique, idea, whatever, constant improvement. Also, I'm going to be using a set of squeezer dies that I made a long time ago, back in the early development of the squeezer, and then kind of never used. I got distracted by something else, probably NQALHA production, working in the machine shop, some other idea, something, and these dies have just been unused for the longest time, and I'm kind of curious, well, do they actually work? So the pattern that I'm attempting to make here is a geometry that is a very common geometry that a lot of glassworkers use, made of intersecting circles. Some people call it a sacred geometry. I don't know where that word came from. I just call it a cool geometry. But turns out that even though the pattern is made of intersecting circles, it's possible to break it up into triangular sections, and I've got a little diagram here showing how that works, and each triangular section having a kind of a circular design element in each one of the sides, and then you kind of like make them and pull them down and stick them together, and hopefully the result all comes out looking cool. So I've got the set of custom dies for the squeezer with what I think is going to be the correct radius. I've calculated the amount of glass that I need to gather up and form up in order to make the pattern work. And so here goes. Let's see if this thing works. I'm going to start off by gathering up some star white using the NQALHA. I found that the NQALHA is an excellent tool for doing gathering of a color rod onto a larger piece. Let me get my flame adjusted here, clean up the crappy end a little bit. So for those that don't know, and it's really hard to know in advance who's going to be watching these videos, if anybody even watches them. But when I was starting out in glasswork, I learned that some colors of colored glass are very, very sensitive, and if you overheat them, you can boil the color. And I became very sensitive to any sign of boiling, and then I started using star white. And I noticed, wow, that certainly looks like a lot of boiling, even when I'm being gentle. And then one of my teachers told me, no, that's not boiling, that's trapped air. That the star white actually has trapped air in the material. And what I'm doing now with the NQALHA is rotating at one speed. I'm rotating with my hand a little bit faster, so I'm kind of twisting the color rod, the star white rod, as I'm melting it in, and I'm noticing that little bit by little bit there's like little air bubbles that are just popping out. And I actually discussed this with Abe at North Star, And he said, yep, Star White has air in it. And he went into a variety of technical reasons why it happens and why it's difficult to control. And even though they know about it, evidently they do the best they can, and it just is a kind of part of the nature of the process used to make it. But it turns out that if you're aware of it, and if you carefully work the material and just watch the air escape as you're twisting the material, you can get a pretty nice uniform air-free material. So little bit by little bit, I think my gathering technique on the NQALHA is improving a lot. When I first started doing it, I was finding it somewhat difficult to make a consistent gather, but I think I'm getting better at it. And like I said before, this is one of the operations that works particularly well on the NQALHA. So I think a two-rod gather is going to produce the correct size blank. And because I am interested in seeing how the pattern looks, I'm using the most contrasting colors I can. I'm going to be making this a black and white pattern, and if it turns out to be a successful result, waiting for it to stiffen up a little bit here, if it turns out to be a successful result, I'll probably try other combinations in the future, but a lot of the development of the squeezer and the squeezing dies, it's all experimental, it's all R&D. I don't have an expert squeezer teacher to help me learn how to use my invention. So, kind of like I'm on my own, but as someone who's been an R&D engineer professionally for about 40 years, I'm real comfortable working on my own when I don't know what I'm doing. I'm just figuring it out. Of course, as the squeezer matures and as more glassworkers start using it and hopefully sharing what they've learned with me, I think the glass community in general will benefit from everyone who uses the machine and learns how to do it and decides that they like sharing, which of course is one of my favorite rants, that all of science, engineering, art, music benefits when ideas are shared. And I have the greatest respect for teachers and criticism for those who keep secrets. You know, sharing is good, teaching is good. I may not know much, but I show what I know. So, just kind of going on here, working at the edge of the far flame, because it's always a balance, trying to get the job done quickly, because this is a kind of a boring thing to do, and the temptation is, hey, I want to get this over with. And of course, having the machine do half the work makes it a little bit easier to go slow. But of course, there's the temptation to want to go fast, but there's also the caution of don't want to blister the color, overheat the color, boil the color. And at the same time realizing that, well, yeah, a lot of those bubbles aren't boiling. That's air escaping. So if it was easy, I'd be bored by now. So I still haven't worked out an extremely detailed plan. I'm kind of gonna just go with it, just gonna see how the pattern comes out and see what to do. But each individual triangle is only a small part of the final pattern. And so I need to come up with a strategy of, do I just make a bunch of little triangles and then chip stack them together? Or do I make a bunch of larger triangles and then assemble them together, pull them down, and basically make a bunch of sub-assemblies that are assembled into the final assembly? And then, you know, what kinds of distortions? Every time you do a pull, every time you do an assembly, you introduce distortion. And, you know, what's going to produce the cleanest pattern? And I don't know. May end up doing this 3 or 4 times to find what the best result is going to be. So after I gather up this blank, I'm going to form it into the cleanest and nicest cylinder that I can get, trying to hit my target dimension, and then I'm going to stripe it with black, stripe it on the NQALHA using a hand torch. I'm using a fairly small kind of oxidizing flame on the Mirage section of the Delta Mag. And I find that this gives me good results when I'm doing the kind of work I do. Using a slightly larger center fire and a fairly small oxidizing flame on the Mirage flame. And that's one thing that I've learned along the way in my glassworking adventure, is how important all of the details of flame selection are. And it seems like every time I work with my teacher or watch a more experienced glassworker work, I notice different things about the type of flame they select, how they select different flames for different operations. And there is a lot of complexity in glasswork. So I kind of got, my big end is a little too big, so I'm going to tilt up a little with the NQALHA. Let gravity have a little bit of an effect. And this brings up an important point for those who are interested in learning the NQALHA, or trying to figure out, well, what can it do, what can it not do, what's it good at, what's it not good at. And the thing that I tell most new NQALHA users, the less you use the twist axis, the better. A lot of traditional handwork technique relies on a fairly active two-handed style where it's kind of hard to do this work and improvise a narration at the same time, so I kind of have to pay attention and then try to talk and then try to pay attention. So I'll just go ahead and just let my piece hang out in the far flame and just do a bit of an educational interlude here that a lot of handwork technique, glassworkers do this all the time. Just looking at it, looking at different angles, letting it fall, letting gravity, looking. That technique does not translate well to the NQALHA. The NQALHA does have a twist axis, and it's very useful to change it, but the best way to use the NQALHA is pretty much set it and forget it, where you pick a twist angle that's going to work for you, and then stick with it. The very active twist, people who have tried it, the first thing they notice is, wow, this is harder than handwork. I'm dragging around this large inertial mass, and my hand is getting tired. Well, my answer is, so don't do it. It's not the way you use the tool. So I'm getting very close here to achieving what I wanted to achieve, which is a uniform cylinder, and it looks really smooth. I don't see any really disgusting stuff on the surface. Switching to handwork here for the final shaping. Actually looking quite good. And I typically work with about 3-inch long pieces. The squeezer die height is 4 inches, and I remember having discussions with other glass workers during the development of the squeezer, where one guy said, oh no, 4 inches is way too much, you need to be 2 or 3 inches. But I've found in my exploration that starting with a 3-inch piece, and there you can see that's a kind of a smooth, nice, uniform 3-inch piece. Starting with a 3-inch piece is a good thing, because as I squeeze, the piece tends to elongate, and sometimes at the end of the process, I end up with a 4-inch long piece. So just rearranging the shop a little bit, getting my Mirage hand torch from the other workstation. I now have 3 workstations in the shop. I have the NQALHA bench and the lathe area and the chip stack assembly fixture thing area. So, okay, so now I'm going to be using the NQALHA for striping, and as I've said before, I find this to be very intuitive to me. Because striping with a hand torch on the NQALHA feels more like welding. And since I'm a welder, it definitely seems to make a lot more sense. And of course I understand the traditional method of striping with the bench torch. Many glassworkers have great success with it, but for me, I find striping on the NQALHA to be much more intuitive, and I think I get a better result doing it this way. But of course, all tools, every tool user uses their tool a different way. Some people like one particular way of doing things. That is way too fast. So, another thing that I'm doing, it's very important when doing a stripe like this to not overheat the substrate. The surface that I'm striping onto needs to be hot enough for the glass to stick, but if I have the substrate too hot and my striping rod too cold and I push too hard, I get some really nasty divots. And so I'm working on developing the technique of have the substrate pretty cold, hot enough to stick, but not hot enough to deform, and then very gently, don't push too hard on the striping rod. Make sure the striping rod is nice and soft and melted, and very gently and uniformly get the nicest, cleanest stripe that I can get. And then of course when I'm just doing something with the hand torch in the air, always be aware that I'm not setting something on fire. And I also kind of wiggle the hand torch around a little so I don't overheat and blister the surface of the rod. A couple of my teachers have said that it's better to rotate the rod while striping, and even though I agree that that makes perfect sense, I haven't developed the technique yet, and for this experiment I'm going to kind of like go with what I know. But I think that learning to rotate the rod while striping is a great idea and will result in more uniform heating and less possibility of boiling or degrading the rod. And of course, being an inventor, I think, well then, I'll just invent a rod holder with a motor in it. Maybe I will. Uh-oh, getting very close to the end here. Uh-oh, I'm overheating my rod holder. Uh-oh. Oh, that was probably a little too close for comfort. Okay, there we have it. So switch back to rotation mode. Start off by applying some heat on these ugly nubbins and knock them down. I haven't yet learned to do a really nice, neat pull-off. Some of the Marini makers that I've seen just do such a nice, neat pull-off at the end of a stripe, and so many techniques to learn. But then again, I've also seen expert Marini makers that just don't care and put a giant-ass ugly booger at the end and say, it doesn't matter, it's all trash, I'm not going to use the end anyway. And they just work fast. So, just kind of melting in the surface, starting at the far end, using a little bit of paddle, but of course every time I touch it with the paddle I'm cooling it down, so I got to resist the urge. Of course, you know, having experience on the wood lathe and metal lathe, where the tool is almost in constant contact with the workpiece, not almost, it is in constant contact with the workpiece. Kind of weird to get used to glasswork where every time you touch the piece with the tool, it becomes less workable. Just moving down the piece. Going slow because the machine is doing all the work and all I have to do is stand here and attempt to improvise interesting narration. But that's one of the advantages of the NQALHA, is that it makes it easier to go slow. I'm not getting tired doing this. And so, since I am using a rather small flame to avoid boiling the surface, it doesn't bother me at all that it's taking some time. And then I'm reversing a little to control twist. Since this is a solid color over a solid cylinder, twist doesn't matter, but it's kind of good just to get into the habit of making straight glass. So when twist does matter, I have the skill practiced to be able to control it. Controlling twist is one of the more difficult things to do on the NQALHA because it's a single-sided lathe. Controlling twist on a traditional glass lathe pretty much automatically comes with the geometry of the machine, although if you're too aggressive with your paddling, you can introduce a twist in the center of the pattern on a traditional lathe. But in glasswork, being overly aggressive is often not a good idea. Although, you know, that being said, every glassworker is different, and I've seen the spectrum of glassworkers that I've watched or learned from. Some are so gentle you can't believe how gentle they are, just gentle and slow, and others are aggressive and brutal. I mean, they just beat up the glass, and they all achieve success in their own way. So, starting to get a little bit difficult to manage here on the NQALHA. I think I'm hitting my target size very well, letting it droop. Pause momentarily, stop rotation, let it droop when it gets off center. When the project was first started, my collaborators told me that, oh, what you want is pause and reverse to control droop, because that's what hand workers do. Turns out that on the NQALHA, it's not as effective. That pause and resume the same direction is a more effective strategy on the NQALHA. So now I'm switching to handwork for the final shaping. I think I'm hitting my target size, almost exactly what I intended, but, you know, I'm not sure my target was correct, being the first time that this has been done. So, piece is looking very shiny. Surface is looking very nice. I have a tiny number of little micro bubbles that, even though I was really careful to avoid them, they seem to just want to grow. Hopefully they won't be a problem. Hopefully, with all the work that's going to be done to this piece, they'll either close up or in some other way not be a major problem. So here we go, into the squeezer. And as always, the piece bulges in the center, that's the way it works. That's what the squeezer does. And part of learning to use the squeezer is to learn to manage that. So now that I've started to form my shape, I'm going to be doing some differential heating. The ends of the blank tend to be troublesome because the far end is exposed to air where it's radiating away all of its heat, and the near end is connected to the punty, which is a heat sink. Somewhat. Cold glass is an insulator, so not that bad, but still part of the strategy here is going to be to use gravity, a little bit of marvering, squeezing, and differential heating to try to get this piece a little bit more parallel on its sides. Going back and forth between the Mirage flame and the Delta Mag flame. The Delta flame gives just more flame. It gives more surface coverage, and so it's possible to cover a large area more uniformly with the large flame. I don't use the large flame because I want it hotter. I use the large flame because I want it more uniform. So it's going to take several squeezes before I get this pattern. And of course the challenge with this pattern is that geometrically, if you just look at the diagram, the the pattern has sharp corners. And of course, even with the squeezer, you're not going to get sharp corners out of glass. So I'm trying to get the sharpest corners I can, and I may actually stripe on a stringer. I think I need to build a little more core heat inside the piece. Not feeling like it's doing much, although at this stage it's not going to do much. The pattern is almost complete, the dies are almost touching, and there's not a lot more going on, but anyway, I was possibly imagining when it comes to the next step of striping on a smaller stringer, and you notice that I'm using handwork for this operation because I don't want to overheat the corners. The corners are getting sharp. Every time I do it, they get a little sharper, and as they sharpen, they become very easy to overheat. I'm standing on the squeezer, and yes, as I've said in other videos, the squeezer is designed for this. The squeezer has been through multiple revisions that mostly consisted of making it stronger and more precise, going from a bicycle chain to not a bicycle chain, going from bicycle cable to a number 25 roller chain. And now I can stand on it. Part of what I like to show in these videos is how the NQALHA is a useful tool, but it doesn't do everything. It's an assistant that, at least for my work, the proper use of the NQALHA is to go back and forth between handwork and the NQALHA, using the NQALHA when I need the control that only handwork can provide, and using the NQALHA for the boring stuff where I'm getting tired, starting to rush maybe because I'm getting tired. And unlike a traditional glass lathe, where the setup is a little more, there's a little more to it, there's a little more you have to do to put a piece in a glass lathe. On the NQALHA, it's easy in, easy out. So, little bit by little bit, getting the pattern a little bit better. And of course, as I'm trying to build core heat, I'm getting kind of double duty out of the squeezer. Not only is it affecting the geometry, but also every time the surface of the glass touches the graphite, the surface freezes, but the core retains whatever core heat it had before it was put in the squeezer. So by doing this repeatedly, I can end up building and preserving core heat without the fear of overheating the surface, since every time I squeeze, I'm getting a little bit of surface cooling and surface recovery. Now I'm pushing downward on the squeezer here, to try to fix up the punty end of the piece that still has more taper in it than I would have liked. And it's difficult to get heat into the punty end because the more I try, the floppier it gets. So, and then of course, you know, it's Marini. It'll never be perfect. The ends are always somewhat sacrificial, but always nice to preserve as much of the pattern as I can. Of course, next time I do it, I might consider pre-forming a triangular large moil, because right now I'm just on the end of a 12 mil rod, and as I try pumping heat into the punty end, I'm always in danger of going out of control, although I am actually achieving somewhat of my goal here, so all learning experience. This whole process, it's all an experiment. It's all R&D. And it'll be interesting to see if far more experienced glassworkers start using the squeezer and end up teaching me how to use my invention. So that is getting substantially more under control, more parallel. So I think I am accomplishing my goal here. And one thing I've learned about glass in general, and using the squeezer in particular, there comes a point of diminishing returns. There comes a point when you got to look at it and say, that's good enough. It ain't getting better. So, going to get a little more uniform core heat here using the mag flame, and of course I've got a fairly smallish mag flame. It definitely isn't in fire breathing dragon mode. Fairly smallish mag flame, but it does cover more area more uniformly, and just slowly trying to build some core heat, concentrating as much as I can on the ends, knowing that if you concentrate on the ends, the middle kind of takes care of itself, because the middle has hot glass on both sides and the ends don't. Standing on the squeezer, and I'm standing and holding, because even after the outside of the glass freezes, there's still plenty of core heat, and I've noticed that sometimes I can see movement, not much, just the tiniest amount of movement in the squeezer if I stand and hold it for a while, for longer than I think would be reasonable. When I first started using the squeezer, I did all fast squeezes. And now that I have a little more experience, I'm noticing that Sometimes the glass keeps moving, although I am right now getting to the point of diminishing return where it really is getting to be about as good as it's going to get. So this will be the final squeeze, and it's not perfect, but it's actually quite good. So the next step in the operation I'm going to get this guy a little bit back on center. It kind of Now that was a good illustration of going from dangerously out of control to back on center using the NQALHA starting and stopping. So the next operation, while this is cooling, because I want to make sure that it's relatively cool so I don't distort it while I'm striping, I'm going to switch to the 1 7/8 flat dies, and of course, knowing that the circular dies have just been in contact with red hot glass, I put on the insulating glove because I don't want to touch a hot graphite. So here we go with the, I kind of don't like that one. Yeah, here we go with the now that's interesting. Got a bit of a problem here, but it will not be a fatal problem. As I said, the system is still under development, and occasionally I do run into a little geometric problem where I look at it and go, oh man, I thought I solved that one. I thought that one was already under control. So now, I'm gonna attempt to complete this pattern by adding some white to the circular divot that I just made on the squeezer. Once again, being careful to not push too hard, make sure the color is nice and soft. Here I'm coming right up to the edge, but I'm not going to go over the edge. I actually thought about the possibility of striping the outside edge with a stringer, but I'm just going to see how this method works. See if this accomplishes what I need to accomplish before getting too fancy. Carefully point the hand torch in a direction where there's nothing that's going to catch fire. Grab my rod holder. Make sure that I don't let my little moily thing get too cold. Again, I'm overheating my rod holder, getting very close to the danger zone. Moving around the torch flame a little bit. Now the center needs to be thicker than the edges, so adding a little more to the center. And exactly how much to add, well, that's going to come with experience. I suspect that as I learn this process, I will develop some tricks and some ways of gauging what's the right size. But for today, this is the first guess. of running out of things to say here. Just one after another, putting down the stripes. And yes, I have done striping the traditional way, the way my teacher showed me. And yes, I've seen work done by Marini artists who use the bench torch method very successfully, and I know that the traditional method works. This just kind of makes a little more sense to me. But as I said, everybody has different ways they use tools and different things that feel comfortable for them. So one of these days I'm going to probably melt this rod holder. So now that it's been cold for a while, let's get it hot and happy again. The noise you hear in the background is my oxygen system. I have a do-it-yourself oxygen system with both low pressure and high pressure compressors. I have 2 home fills hooked to a 5 liter per minute oxygen concentrator. Let me make sure that my piece isn't getting out of control here. And 3 oxygen concentrators hooked up to a low pressure system, and the low pressure system and the high pressure system are connected together with check valves. So when the low pressure system runs out of poop, the high pressure system automatically takes over. Got a little off center there. Let it droop. Back on center. Following the recommendation that seems to be common among glassworkers, I only pump my high pressure tanks to 1,000 psi because I've been told that it preserves home fill seal life. Of course, replacing home fill seals is not hard. I figured out how to do it and made a video about it. So there's no great mystery there, and anybody who is proficient with the use of hand tools, anybody who's ever taken apart a motor, done any mechanic work, should be no big deal at all. So just kind of standing back a little bit, getting ready, kind of getting hot in here. That's one thing about working with Marini, with large solid pieces. The radiant heat can get pretty extreme. Okay, so switch to handwork, get Mr. NQALHA out of the way. And prepare for the first squeezle, knowing that the squeeze has the possibility of distorting my inside shape. So I'm trying to, in this case, concentrate my heat instead of trying to build core heat I'm trying to concentrate my heat on the surface, which may be futile, but still, what I'm attempting to do, I'm working a little closer to the flame and trying to smooth out my outer surface without driving the imperfections in the outside striping, driving those into the pattern and distorting the pattern. It may actually be that pre-making an appropriately sized billet and then hot assembling it onto the preliminary shape may be a better approach than striping. But we'll see. There's a first time for everything. The great benefit of the squeezer is being able to squeeze shapes like triangles and hexagons and other various different forms. Obviously, glassworkers can use paddles and marvers to squeeze squares, and so using the squeezer for a square, well, you wouldn't buy a squeezer just to do squares, but if you had a squeezer in your shop and you wanted to do squares, it does squares really well. More precisely, more uniform than you can do with hand tools. Going to be this is very early in the history of the squeezer. I just recently released it to the public after years of prototype work in my shop, and I just sold the first 2 to customers, and I have another unit in the shop of my collaborator, and so going to be interesting to see how people end up using this tool. I'm realizing now that I definitely, no question about it, should have built this piece on a moil, either that or transferred it to a pre-made moil. That the 12 mil rod is a great way to start a gather, but at this point I'm realizing that I really would be a lot happier with a big moil. So welcome to the lack of planning department. But, all that being said, not coming out that bad. I always try to perfect things, but that also leads to being very critical, and this is, I can imagine it being better, but it's not bad. It's actually looking fairly nice. somewhat difficult to control here because of my undersized moil and undersized punty, but I'm still doing pretty good. Okay, now I'm going to start standing on the squeezer, and boy, that is not looking bad at all. I tell you, that is not looking bad at all. Trying to smooth out, there's a little bit of, I can still see the stripe lines at the ends. And knowing that the end is not going to be the best part of this pattern, may actually end up being a throwaway as I pull it down and get a knuckle. I'm not too horribly concerned about it, but next time I'll definitely use a moil. Either build it on a moil or transfer it to a moil as it gets going. So now I'm very close to the torch face, just trying to drive some heat into the surface to clean up my surface, because I really don't have any more core shaping to do. I'm just trying to even out the surface in preparation for pulling. So this will be the last squeeze. Stand on the squeezer, hold, and that is what it is. So a little Bunsen action going here. And I am going to make up a moil for the other end. Should have done this in advance. Boy, it's hot in here. Boy, it's hot in the hot shop. Glassworking may be cool, but there's nothing cool about glassworking. Well, that's a very, very nice triangular moil. Here's an example of, let's see if you can see that, how sharp a corner you can get with the squeezer. Bunsen off. Someday I'm planning on experimenting to see if it's possible to do poles on the NQALHA. At the moment, I definitely don't have the skill, and so I'm going to kind of fall back on what I already know. But there is definitely reason to expect or believe that it might be possible to do poles on the NQALHA. I'm concentrating the heat on my newly welded moil end because this is going to be the better end of the work. The punty end is going to be kind of like the sacrificial throwaway end. Of course, I don't want to let it get too cold, but I definitely have a very undersized punty on that end. This is the part where I usually start having trouble. Kind of hard to avoid introducing a twist in a pole like this. But little bit by little bit, I think I'm getting better at it. Yes, I'm having exactly the problem that I thought I would have. Getting a giant-ass ugly knuckle. and my puller is threatening to let go at any moment. So this will be resized, so it doesn't have to be perfect. And if I spend any more time dicking with it, it's going to get less good. Fortunately, for those of us with less than perfect pulling skills, resizing in the squeezer can fix almost anything. So that is the result. Parts of it look pretty uniform and pretty untwisted, but like I said, it can all be fixed. So into the kiln it goes. Thank you for watching. It's been fun.